We now discuss the solution of a problem from the section Vector Algebra, and the problem is on the length of the projection vector. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the Shift 1. The problem is, let the vector A is equal to I plus j plus k, vector B, and vector C is equal to j minus k be three vectors such that A cross B is equal to C and A dot B is equal to 1. If the length of the projection vector of the vector B on the vector A cross C is L, then the value of 3L square is equal to. So, we are given a vector A B, a C such that A cross B is equal to C and A dot B is equal to 1. And the length of the projection vector of the vector B on A cross C is given to be L. We have to find 3L square. We now discuss the solution of the problem in detail. We are given three vectors A, B, C, where A is I plus j plus k and vector C is j minus k, and the vector B is not given, but we have to find using A cross B is equal to C and A dot B is equal to 1. Agreed. Now first we want to find the vector B. Let B is equal to xi plus yj plus zk. We first use A cross B is equal to C. A cross B is the determinant whose first row is I, j, k, whose second row are the components of A, that is 1, 1, 1, and the third row the components of B, x, y, z is equal to C is j minus k. Expanding this determinant along the first row, we get this, and that is equal to j minus k. Now these two vectors are equal. The corresponding the coefficients of I, j, k on both sides must be equal. So that will imply z minus y is equal to the coefficient of I here is 0 minus z minus x, the coefficient of j on the left hand side, the coefficient of j on the right hand side is 1. Similarly, y minus x is equal to minus 1. And from the first one, z is equal to y. From the second one, you get x is equal to z plus 1. From the third one, you get x is equal to y plus 1. This will imply x is equal to z plus 1, correct? And y is equal to z, correct? And z is equal to z. And to find z, we will use A dot B is equal to 1. Now, therefore, B is xi plus yj plus zk is equal to x is z plus 1 I plus zj plus zk, and we will find z using the second condition A dot B is equal to 1. Now, A dot B is equal to 1 will imply A dot I plus j plus k dot B. The B is z plus 1 I plus zj plus zk. Take the dot product, and that is equal to 1. And when you take the dot product here, you will get z plus 1 plus z is equal to 1, and that is 1 1 cancels on both sides. We get 3z is equal to 0 will imply z is equal to 0. So when z is equal to 0, x is equal to 0 plus 1 1, y is equal to 0, z is equal to 0. So now What is the vector B then? Therefore, the vector B is xi plus yj plus zk is I only. B is equal to I. Thus, we have found the vector I. Now, we proceed further in the next slide. So, we have these three vectors now. Given L is the length of the projection of this vector B on A cross C. And we have the formula, the projection of the vector x on vector y is given by x dot y by mod y. Now we want the length of this, length of the projection. Length means the modulus you have to take. So this is equal to the projection of B on A cross C is B dot A cross C by mod of A cross C, modulus because it's the length, and that is equal to mod of the B dot A cross C, that is the numerator, by the mod of A cross C. In this A cross C we have to, A we know, C we know, A cross C we have to compute. So A cross C is the determinant I, J, K, and the second row is the components of A, 1, 1, 1, the third row, the components of C, 0, 1, minus 1, expanding along the first row and simplifying, we get minus 2i plus j plus k. Right, what is the length of that A cross C? So, mod of A cross C is under the square root of minus 2 square plus 1 square plus 1 square, that is under the square root of 6. Now, B dot A cross C we want in the numerator, B dot A cross C. B is I dot A cross C is minus 2i plus j plus k. Take the dot product, you will get minus 2. So, therefore, we go back to the formula, L is equal to mod of B dot A cross C by mod of A cross C, that is equal to mod of minus 2, because mod of B dot A cross C is minus 2 by mod of A cross C is root 6, that is equal to root of 2 by 3. Squaring on both sides, we get L square is equal to 2 by 3, and this will imply 3L square is equal to 2. That's what precisely we want in the question. So that is your answer. 3L square is 2 is your answer. 3L square is given a blank. In that blank you have to put 2. The answer is 2. So that is the discussion of the solution of the problem from the vector calculus on the length of the projection vector. I am sure you have understood the solution of this problem. Go on working out some more problems on these lines from the section vector calculus or vector algebra, and I wish you all the best. Thank you.